Hi, welcome to our next complex numbers video. Well, we're finally up to the videos where we start introducing what are complex numbers. Hooray! A complex number is a number that is written in the form of a plus or minus bi. For example, 5 minus 4i can be written in this form. 2 plus the square root of 5i is written in this form. 5i can be written in this form because we have 0 plus 5i. And so is the number 7. We can write that in a complex number as 7 plus 0i. So all of these are complex numbers. Mathematicians have defined I squared is equal to negative 1. And therefore, if we take the square root of both sides, I is equal to the square root of negative 1. Now you're going to have to remember this. This is not provided on any formula sheet. How does that help us with this definition? We know for years, the square root of 25, there are two solutions. But we've never been able to take the square root of a negative number, up until now. We could take the square root of negative 25 and write it as the square root of 25 times negative 1. And we could use our surd notation property and break it up into the square root of 25 times the square root of negative 1. And because we've got this definition over on the left, I is equal to the square root of negative 1, we could replace this with I, and therefore we get the square root of 25 times I. Now, because we have two solutions to the square root of 25, we end up with two solutions to this problem. The first solution is going to be 5i, and the second solution is negative 5i. And coming back to our idea of complex numbers, written in the form of a plus or minus bi, we could write the two solutions as 0 plus 5i and 0 minus 5i. So now we've got a way to solve taking the square root of a negative number. A complex number is made up of a real part, which we call a, and an imaginary part we call b. We often use z as a letter, a very common letter for complex number, equal to a plus or minus bi to represent a complex number. But we use other letters as well. Here are some examples. Example 1, z is equal to 2 plus 3i's, real parts and 3 imaginary parts. Example 2, z is equal to 7. So we've got 7 real parts and no imaginary parts. We have example 3, no real and 5 imaginary. And example 4, we have w equal to 4 real and negative 1 imaginary. Example 2 is called purely real because we have 7 real parts and no imaginary parts. And example 3 is called purely imaginary because we have no real and 5 imaginary parts. So when we write a complex number, we have a real component and an imaginary component. All right, let's have a look at what this means visually. Here's a number line we've been studying for years and years and years. And on this number line, I've plotted the point 5, which is 5 real parts. 5 numbers. We're now going to introduce a vertical axis. So we have a horizontal axis, which is still our real component. And the vertical axis is now the imaginary component. Don't get confused with an x and y axis, although it works with the same idea. It's not the same thing. It's called an Argand diagram, and it was named after the mathematician Jean-Robert Argand. Let's have a look at this complex number. This complex number I'm going to call z, and it's equal to 4 real parts and 2 imaginary parts. This complex number, which I'm also calling z, is equal to negative 4 real parts and 1 imaginary part. This complex number, which I'm going to call w, is equal to negative 5 real parts and negative 2 imaginary parts. This complex number, which I'm calling u, is equal to 3 real parts and no imaginary parts. Remember, we call it purely real. And this complex number, which I'm calling z again, is equal to no real parts and negative 1 imaginary part. So this is purely imaginary. No real parts and just imaginary components. All right, well, we're going to continue exploring complex number in the next few videos. So thanks very much for tuning in for this video.